Hey folks, and welcome to another edition of Zog Science. Today we're going to be start moving around. It's so stupid. Hey folks, and welcome to another edition of Zog Science. Today we're going to be taking a look at isotopes and radioactivity. How do we write nuclear reaction equations? So I'm going to do a couple of example problems here to help show you how to do it, and then you'll complete the rest of this on your own. So taking a look at our first part of this worksheet, the first part of this, we're taking a look at isotopes. And the purpose here is to hopefully have the right tool selected so I can actually draw. The purpose of this first portion of the activity is to work on isotopes. Now, when we're talking about isotopes, basically everything that we have done so far is going to be the same, right? So all the counting of protons, neutrons, and electrons, all the rules that we've been talking about, they're all the same. The only thing that's different is that now when I'm telling you about the element, when I give you the name of the element, I'm also giving you the mass. So for example, chlorine 37, this 37 is referring to the atomic mass, okay? Carbon 14, the 14 is referring to the mass. Oxygen 18, that is referring to the mass, okay? So those are kind of three different ways that you'll see these. So we can just go ahead and pop these in. The mass for each of these would be like that. Now, in order to actually complete this, we also need to know the atomic number, right? If we don't know the atomic number, then we won't be able to know our protons and electrons. So the atomic number is what you would find on the periodic table. So you have to go to your periodic table, look for chlorine, find chlorine, you'll see that the atomic number is 17, okay? So now that I know that the atomic number is 17, we know that the number of protons is 17 and the number of electrons will also be 17, because remember, those are always going to be the same for now. The final thing we need to do is to find out our neutrons. And remember, to find the number of neutrons, we take our mass and we subtract the number of protons. So 37 minus 17 is going to give us 20, and so our number of neutrons will be 20. So all the rules that you've done before, they're all the same. The only thing that is different is the fact that now the masses are given to you over here in the element name. Okay, so you have to look for that in order to figure out the mass. You should not be looking on the periodic table to find the mass, because these are isotopes, right? The masses are different than what you might see on the periodic table. You do need to go to the periodic table in order to figure out the atomic number, okay? All right, so that's all the same as what we've been doing before, just a little bit of a variation there with the masses to figure out the isotopes. What is very new is how do we write nuclear reactions? All right, so when we're doing nuclear reactions, what we're going to be trying to do is we're going to try to be filling in the missing particle, okay? And the way that we do that is that we look at the mass and we look at the atomic number. And so the key thing is that we want to be looking at this arrow, because this arrow is bisecting the two different times, right? It's going to be basically saying what happened before and then what happened after. And so before, what we have, this is our radioactive isotope, and then after, this is what's going to be happening once it becomes stable, once it has emitted that radiation. In this case, we're emitting a beta particle, okay? And beta particles are a little bit tricky because even though it says -1 here, what actually is happening, remember, is that one of our neutrons, right, is changing into an electron plus a proton. And so what's happening is that actually our atomic number is going to be increasing by 1. And so the way that we want to think about this is that we want to think that 19 is equal to -1 plus something, right? Or another way to say that would be 20, or something -1. So something -1 is equal to 19, and that is going to be 20, okay? So another way to kind of think about this is that if we take this and we split it in half, right? We look at just the atomic numbers on the bottom. They need to be equal on either side of the arrow, all right? So again, 19 is equal to -1 plus something, and that something is going to be 20. If we look at the top, right, this is a 0, so 42 is equal to 0 plus something. Well, that's still going to be 42. Now the final step here is that we want to take a look at our atomic number, and whatever our atomic number is, we are going to look that up on the periodic table and see that that is calcium. And this is a full and complete answer. You have to make sure that you are including your element symbol there. Okay. All right, let's take a look at the second one here. In this case, this is going to be alpha decay, right? We have an alpha particle that is being emitted here. Okay. Same idea though. Let's split this in half. Okay. And what's on the left-hand side of the periodic table has got to be equal, or of this equation has got to be equal to what's on the right-hand side. So in this case, we have 23, right, is equal to 2 plus something. Well, 2 plus 81 gives us 83. Same thing with the mass. So it's going to be 214 minus 4 is equal to 210. And then what we have to do is we have to look up this 81 on the periodic table. Atomic number 81 is thallium. Okay. Now, if we look down here at these next problems, you'll notice that the blank space is the first one, and then the particle is over here on the right. That doesn't matter. It's just like regular math. 3 plus 2 equals 6, or 2 plus 3 is equal to 6. So you still just want to be finding what are those missing particles. Last thing I want to talk about is what do you do if it is a gamma decay, okay? So if this is a gamma decay, right, a gamma particle, well, if we have a gamma particle, you'll notice that it's 0, 0, so there's going to be no change. And if it's still the same atomic number, it's still going to be beryllium, okay? You'll notice for these last 4 down here at the bottom, you are trying to find out what is on the left of the arrow, right? What did we start with? What was the unstable nucleus? And so you'll be using the exact same rules, right? You want to be finding what is the mass, what is the atomic number. Here you can just kind of easily add them up, a little bit easier to do with that one, okay? All right, thanks for watching, y'all. If you have any questions, please let me know.